questions from you guys? Last time I asked you guys to do what, like 1 through 6 in worksheet 1? Are there questions from that? Anybody questions?
Are you going trick-or-treating today?
No, not on my to-do list.
Maybe the kids?
Our neighborhood did our trick-or-treating last night. And considering it's another school night tonight, we're probably not going out again.
Never hurts to run another round.
She's 3.
Oh.
You know. All right. Fair enough then. No questions on the previous homework. So we'll kind of pick up where we had left off and step forward a little bit. So last time what we had looked at was okay, thank you. We had asked you guys to do something like this. Right? We'd ask you guys to do something like this. To find... Shh. Stop talking, please. Thanks. Sine inverse of root 2 over 2, where that angle is between 5 pi over 2 and 7 pi over 2. So first things we did was we wanted to figure out what quadrant we should be looking for our answer in on the unit circle. So we remember that on the unit circle, sine is equal to y. And the place the y's are positive is in quadrant 1 and in quadrant 2. Next, we want to look at what quadrants fall between 5 pi over 2 and 7 pi over 2. Since these are positive angles, we know we're going to be rotating counterclockwise, starting at the positive x-axis. So half a pi, 1 pi, 1.5, 2, 2.5, and then from 2.5 to 3, and then from 3 to 3.5. So this was quadrant 2 and quadrant 3. So I know the answer I'm looking for lies in quadrant 2, because that's the thing that's true for both of those. Olivia?
Is that, like the term on the right, is that 7 pi over 2?
Yes. Okay. So once I've figured out what quadrant I'm in, I'm going to go ahead and take a look at my unit circle. Let me grab a copy of that and drop it in. So we're looking in quadrant 2 for the place where sine is y is root 2 over 2. So our answer, at least initially, is 3 pi over 4. Three pi over 4 is 0.75 pi. But I can see right away that 0.75 pi is not between 2.5 pi and 3.5 pi. What do I have to do to it? I have to add 2 pi. So when I make a common denominator, that's going to give me 11 pi over 3. So that's 0.75 plus 2, so 2.75 pi, which definitely is between 2.5 and 3.5. So that's going to be my answer, right? Today, what we're going to be doing is essentially the same process, but this time we're going to start using things that are doing this for angles that we cannot necessarily use the unit circle to do. So this is going to be done with our calculator instead of using the unit circle. But it's you can. I did. Aiden had it.
And you said
Yeah.
we found the culprit.
Yup.
Yes, we. What do you think you're doing?
Mr. Cooling, did you ever find your?
I did. Aiden had it.
Who was it?
Aiden. All right. So let's look at some examples here.
That is 11 pi over 3. That's supposed to be 11 pi over 4.
Oh, yes. Thank you. Of course.
That's good to see.
All right. So let's take a look at this example. So first of all, notice in the directions that we're not looking for an exact value, which is a good indicator that we're probably not going to be using the unit circle. Furthermore, when I look at that value that we're taking the sine inverse of, I notice that that's not a unit circle coordinate that I'm used to seeing. The fact that it's a decimal already gives me pause and tells me that I'm probably going to need to use a calculator to do this one. Everybody's okay? All right, so just like before, I'm going to think about this as sine theta equals negative 0.71. And just like before, I remember on the unit circle that sine theta is the same as y. So I'm looking for the places where the y coordinate is negative. That's in quadrants 3 and quadrants 4. And then just like before, I'll figure out what quadrants lie between 3 pi over 2 and 5 pi over 2. So starting on the positive x-axis and then rotating counterclockwise because my angles are positive. Half pi, 1 pi, 1.5, that's the start, to 2, and then 2.5. So this was quadrants 1 and 4. So the answer I'm looking for is in quadrant 4. Everybody's okay? Same process that we've done before, right? Here's where things will get a little bit different. So what I'm going to do now is I'm going to draw my answer. So it's a standard position angle that I'm drawing. So I know the initial side is on the positive x-axis. And I know the terminal side needs to be somewhere in quadrant 4. Everybody's okay with that? Now I'm going to draw my theta. So 1/2, 1 pi, 1.5, and then I'll get to my answer. Now I'm going to label this angle with the Greek letter phi. So it's just another variable. Again, when we label variables, oftentimes we like to use the Greek letters to differentiate between like a length, which we use our normal alphabet letters. And what I'm going to do now is I'm going to write an equation that relates theta, phi, and this angle that makes up the x-axis that is the other part of phi. Okay, so the angle phi that I'm drawing is always going to be between the terminal side and the x-axis. Okay. So now if I look at my angle theta and that angle 2 pi, which is bigger, theta or 2 pi? Should be able to tell just by looking at this picture. 2 pi is bigger. Why? Because theta doesn't go past it, right? It just stops before it gets there. Everybody okay with that? Should be easy to see that if you can draw your picture well. Okay. So what that means is I'm going to be, since theta is less than 2 pi, should I be adding to 2 pi or subtracting from 2 pi? Theta is smaller than 2 pi. So should I be adding to 2 pi to find theta or subtracting from it? Subtracting. How much should I be subtracting? That angle phi. Everybody's cool with that? So if I'm able to find that angle phi, I then have my angle theta. Everybody's okay with that? Okay. So that angle phi is always going to be found by just doing the absolute value of the inverse function you're given. So we're always going to do the absolute value. And we're just going to use whatever the inverse that we were given was. Now, on my calculator, am I going to bother to find the absolute value command? Or am I just going to do the absolute value part in my head? I'm just going to do the absolute value part in my head, right? It's easy to just make something positive that was negative. Uh-oh, what happened? This doesn't look like a sensible answer. It's a mode problem. What mode should my calculator be in? Radians, because notice that the quadrants that I've been labeling, pi over 2, pi, 3 pi over 2, 2 pi, are all in radians. So I should do that in radians. And that's a much more sensible answer. 549 or thereabouts. Should we do that again? Yeah, but it wasn't so bad, right? Okay. Let's do another. We're going to do several examples of this process because there's some sneaky things that can happen that I need to eventually talk about, but let's get used to the process first before we introduce some of the sneaky things. So we're going to start the same way we've done. I know that this is the same thing as just tan theta equals 3.72. What is tan on the unit circle? Y over x. Excellent. So if I'm dividing two numbers, y and x, and getting a positive, what can I say about both those two numbers? If I divide two numbers and get a positive, what can I say about both of the two numbers? They're both positive or both negative. In what quadrant are both x and y positive? Quadrant 1. And what quadrant are both x and y negative?
3.
Quadrant 3. Okay, so that tells me that. Okay. Now again, I'm going to figure out what quadrants are covered by the angles from 6 pi to 7 pi. So we'll start on the positive x-axis. We're going to rotate counterclockwise because the two angles 6 pi and 7 pi are both positive. So half a pi, 1 pi, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7. So that covered quadrants 1 and 2. So where's my answer lie? In quadrant 1. Okay. Everybody cool? So far so good? Okay. Let's draw our picture then. So draw my initial side. I know my terminal side is in quadrant 1. And I'm going to draw my rotation marks for my angle theta. Now, here's the trick, though. I know theta has to lie between 6 pi and 7 pi, right? So I need to go at least 6 pi around before I stop at that terminal side. So starting on the positive x-axis, rotating counterclockwise, half a pi, 1 pi, 1.5, 2 pi, 2.5, 3 pi, 3.5, 4 pi, 4.5, 5 pi, 5.5, 6 pi, and then I can go to my answer. So I'll label my parts. So there's my theta, there's my phi, and there's my 6 pi, which was the positive part, or the part of the x-axis that makes up the other arm of my phi. So now I'm going to compare my angle theta with that 6 pi. Is theta bigger or smaller than 6 pi? It's bigger than 6 pi. Why is it bigger? Because it passed it, right? Everybody's agree with that? So, since theta is bigger than 6 pi, should I be adding to 6 pi or subtracting from it? Adding, right? How much should I add to 6 pi to get theta? Always phi. Is everybody okay with that? This is usually the most difficult step, is drawing that picture and then getting your equation out of it. But once you get the hang of it, it's very easy. How do I calculate phi again? I do the tan inverse of the absolute value of 3.72. And I just type this into my calculator then. So 6 pi plus tan inverse, and I'll do the absolute value in my head. So the absolute value 372 is just 372. And I get 20.16. Is everybody okay with this? I'm going to point out to you guys that this is checkable, that these problems are checkable on your calculator. Can I show you how to check this on our calculator? So there's two things that I want to check. I want to make sure when I plug theta back in, I get 372, and that my answer is between 6 pi and 7 pi. So there's two parts that I need to check. So if I do tangent of my answer, I should get 372, which is what I'm getting. Everybody cool with that? And then I need to make sure that this answer, 20.16, is between 6 pi and 7 pi. Well, it's bigger than 6 pi. And smaller than 7 pi. So I am certain that I have the correct answer. Is everybody okay with how I checked that? Very easy check, but you have to check two things, right? You have to make sure that it satisfies the equation at the start and that it's in between the two angles. How are we doing so far? Good. Hi, how are you doing?
Good, how are you?
Just fine.
This is for CT.
Okay.
Do not open the envelope until instructed to do so. Here.
I won't. You're welcome. How are we feeling about this process so far? Is this okay? You ready to see the things that we have to be careful about? Okay. Okay. So let's take a look at this one. Here we have secant inverse of negative 2.51, and that needs to lie between 3 pi and 4 pi. So we'll start the same way. So we'll say that, okay, secant theta needs to equal negative 2.51. Do you remember what secant is on the unit circle? Okay, 1 over x. Sure. So where is, if 1 over x is giving me a negative value, what does x have to be? Negative. So what quadrants does that happen in? Quadrants 2 and 3, right? Okay. Now, before we move on, though, I want to point out something. Do we have a secant inverse button on our calculator? No. So we're going to have to do something to this before we get to the end. So here's the trick. I'm going to think about secant as 1 over cosine. Remember that secant and cosine were reciprocals. I might, on my note card, want to write down those reciprocal relationships again. That secant and cosine are reciprocal, sine and cosecant were reciprocals, and tangent, cotangent were reciprocals. That might be something good to remember. Now, if I do the reciprocal of both sides, I can say that cosine theta equals 1 over negative 2.51. Or that theta is equal to cosine inverse of 1 over negative 2.51. And that I can type into my calculator. So I had to do a little bit of extra work there on that first step to make sure I had something I could type into my calculator. Okay, next up, we need angles between 3 pi and 4 pi, starting on the positive x-axis, and because these angles 3 pi and 4 pi are both positive, I'm going to rotate counterclockwise. Half a pi, 1 pi, 1 1/2, 2, 2 1/2, 3, and then to 3 1/2 to 4. That covers quadrants 3 and 4. So where does my answer lie? In quadrant 3. Draw my picture here. So initial side on the positive x-axis. Terminal sides in quadrant 3. But remember, I have to go around past 3 pi before I can stop at my terminal side, right? So a half a pi, 1 pi, 1 1/2, 2, 2 1/2, 3, and now I can stop at my answer. So I'll label my parts. Again, I labeled my theta, that x-axis piece that makes up my phi, and then my angle phi. Now, is theta bigger than 3 pi or smaller than 3 pi? It's bigger because it passes 3 pi, right? So should we be adding to 3 pi or subtracting to 3 pi? Adding, right? Because that'll give me a value that's bigger than 3 pi. Mm-hmm. And what will we add to it? We'll add phi. Now remember, to calculate phi this time, we're not doing secant inverse because that's not on my calculator. I'm going to do cosine inverse of 1 over negative 2.51. So I get about 1059. Everybody okay there? Now to check this, I would check here and here. How do I type secant into my calculator? Actually, why do that? We should check here and here. We wrote it down. I don't need to tell you how to, we don't need to say how do you type secant into our calculator. So 1 over cosine of our answer. Sorry, 1 over cosine of our answer. Gives me negative 251, which is great. And then I need to check to see if 3 pi is smaller than 1059. Yup. And 4 pi is bigger than 1059. Yup. So we're good. We got it. Is that okay so far? All right. One more example, and this is the trickiest situation. I promise this situation will show up on a homework quiz and/or test. So lock in and pay attention here for a moment. What do you notice that's different about this one than the previous ones we've seen? Yeah. We're between two negative numbers, two negative angles. So let's see how that affects things. It makes a difference in several places. So again, we just start by rewriting this as a sine equation. So in the unit circle, I know sine is y. And I know that y is negative in quadrants 3 and 4. Right? You think about it, you're just talking about the stuff below the x-axis. Draw a picture if you need to. Okay. Now, when I do this, again, we're starting on the positive x-axis. But because my angles are negative, which way am I rotating? Clockwise. So this is negative a half, negative 1, negative 1.5, negative 2, negative 2.5. Look. So this covered quadrants 1 and 4. My answer then lies in quadrant 4. Okay. So I had to remember to go clockwise when I figured that part out. I have to remember to do that again here, right? So there's my initial side and terminal side. So negative a half, negative 1, negative 1.5, negative 2. Everybody okay with what I did there? Now, here's my next question. Is theta bigger than negative 2 pi or smaller than negative 2 pi? But it goes past negative 2 pi. Yeah, it's still smaller because theta is more negative than negative 2 pi, right? It's the opposite intuition as before. So we should be subtracting phi in this situation. What do you guys think about what's happening right now? Is this okay? So negative 6.66. Ooh, what a spooky number for Halloween. Should we check that though? Yeah, let's check that. So if we do sine of that answer, I should get back negative 0.37. I do. If I do negative 3 pi over 2, that should be bigger than negative 0.66. It is because it's less negative. And then if I check negative 5 pi over 2, that should be smaller than negative 6.66. It is because that's more negative. So I'm convinced that we have the correct answer. Do we feel okay on this process? Try to go slow through this, do it very systematically, give you lots of examples. We're stopping here. There's still more to do in this first section, but this feels like a good stopping place because this is a skill that is quite important, and I'd like you to spend some time focusing on this one in particular. You guys should be able to do now 7 through 10 and worksheet 2. Yes. So we're going to stop here. This will be due, what is it, the 6th? Would be Sunday? Yep. Okay. Yeah, what's going on, Caden?
My calculator, I don't know what I'm doing.